Hello everyone, let's take a look at our next problem. Okay, we're just asked to integrate 1 over 1 plus x squared. The first thing that comes to my head is is there a trigonometric substitution that works here? Or 1 over 1 plus x squared. I don't think substitution will work, like a direct substitution. Oh man. It's funny how, after so much time, you do start to forget some of this stuff. I'm just going to make a wild guess here. This is a total guess. I think there's some trigonometric thing we can do here, and maybe by trial and error we can just figure out exactly what that is. So anyway, dx is, well, this is sine divided by cos, so this gives us cos squared theta minus cos squared theta plus sine squared theta divided by cosine squared theta d theta. So dx is 1 divided by cosine squared theta d theta. And so then this isn't quite what I want, is it, right? No, maybe, okay, let's try something else. Let's try, okay, x equals secant theta, which is 1 divided by cosine theta d theta. So dx is shouldn't be a d theta here. Dx is negative cosine theta to the negative 2 times times negative sine theta. Which is secant theta tan theta. Does this help me at all? So then the integral of 1 over 1 plus x squared dx is 1 over 1 plus secant squared theta times secant theta tan theta d theta. Just a minute here. Did my first guess actually, did it work? Let's go back a little bit here. Let's go back a little bit here. 1 over 1 plus x squared dx. My first guess was that x is equal to tan theta d theta. Then dx is secant squared theta. Oops, gosh. Secant squared theta d theta. But 1 plus tan squared theta is equal to 1 divided by cosine squared times cosine squared plus sine squared. Right, it's factored out a 1 over cosine, and this is equal to secant squared theta. So this integral is then the same as secant squared theta times dx. This doesn't look like it's helping much, but perhaps, yeah, maybe one of the other substitutions would end up working. You know what? If I ended up with a reciprocal of something somewhere, that would make me happy. Okay. Let's get rid of you. Let's say x is equal to cotangent theta. Just to see what happens. Okay. Is this going to help at all? 1 plus cotangent theta squared is equal to 1 over sine squared times sine squared plus cos squared equals 60 theta squared. So my integral gives me 1 divided by cosecant squared theta times, and dx is negative squared theta d theta. Okay, so I do get the cancellation I want there, so I end up with negative theta. And if I substitute this, so this gives me negative, ooh, hold on, even and odd stuff going on here. Well, I'm going to want, I suppose, negative cotangent inverse x. Okay, so my claim is that, well, you know, I'm going to ignore the constant of integration for the moment. Obviously, we can just add that all at the end. But I'm going to check my answer. I'm just going to take a derivative of this, which I've essentially already done, and make sure we get 1 over 1 plus x squared. Okay, so y is equal to negative cotangent inverse of x, which means cotangent of negative y is equal to x. Now I take a derivative implicitly. Just using some even and odd rules for these trig functions. Okay, now let's differentiate. Derivative of cosine is negative sine. By quotient rule, we multiply by the denominator. And I also need an implicit, I need the derivative of y here. Now I subtract the derivative of the denominator, which is cos y, multiply by the numerator, which is also cos y, and divide by sine squared y. I'm missing a y prime here as well. Derivative of the right-hand side is just negative 1. And so I end up with y prime is equal to negative sine squared of y. No, positive sine squared of y. Okay, the negative signs cancel, of course. Sine squared plus cos squared here gives me 1. Okay, sine squared of y. This is where it's going to be useful to draw a triangle. Okay, so y prime is equal to sine squared of y, which is the same as 1 minus cos squared of y. Hold on. X is cotangent of y, which is cos y divided by sine y. I want to write sine squared of y in terms of x. X squared is equal to cos squared y divided by sine squared y. Maybe another way of doing this. Okay, hold on. So x is cotangent of y. So if I call, so this is 1, this is sine, this is cos, c divided by s is x. So if I call this 1 and this x, here I have 1 plus x squared in the square root, and x is cotangent of y, and I have 1 plus x squared in a square root is that by the triangle, right? Sine of y is 1 divided by 1 plus x squared. Okay, so this gives me sine squared of y is 1 over 1 plus x squared, which is what I wanted. Right? Okay. So y prime is in fact 1 over 1 plus x squared. Do I have a negative sign missing? Because cotangent is cos over sine, which is an odd function. But then that means the derivative should be an even function, right? There might be some funky business going on with signs here, plus or minus. But the general, I mean, I've basically just re-derived the appropriate trigonometric substitution for this integral here. Yeah, but if we want to integrate 1 over 1 plus x squared, there's going to be a cotangent inverse substitution to be made. I'd have to go through all the details here to figure out the sign again, but the main point of the problem is that, yeah, would have saved a lot of time if I just memorized this, but here's why that trig substitution happens to work. Thanks for watching.